Hello, everyone. Well, welcome. My name is Mike Reapy, and I'm one of your volunteer organizers tonight and a former president of the UC Santa Cruz Alumni Association. On behalf of the association, I'd like to welcome you to our monthly speaker series, Slugs and Steins, Lectures from UC Santa Cruz. For those who are new, our Slugs and Steins series engages a UCSC member in discussion with you, the local community of Santa Cruz, and our extended community online. The great physicist Richard Feynman once said, "Everything is interesting if you go into it deeply enough. If you agree with him, you're one of us." We want it to feel just like you're at UCSC among the redwoods, sitting in class, but without homework or tests. First, I'd like to share the UCSC land acknowledgement. The land on which we gather is the unceded territory of the Awaswas-speaking Yupi tribe. The Amamutsan tribal band, comprised of the descendants of indigenous peoples taken to missions Santa Cruz and San Juan Bautista during Spanish colonization of the Central Coast, is today working hard to restore traditional stewardship practices on these lands and heal from historical trauma. Before we get started, we'd like to take a poll to get to know our audience and where you're tuning in from. Please take a moment to answer a few quick questions. They'll pop up on your screen. We'll share the results after we've given everyone a moment to respond. Okay, probably homing in on that. All right, you should be able to see the results now. This is always fun to see where everybody's dialing in from. Most people, just one person, but we've got some couples watching. Kind of equal split here between Santa Cruz County and Bay Area. We've got 5 people dialing in from somewhere else in the US. So welcome, everybody. Great to have you here. So tonight, we raise our steins with not one, but 3 guests. First, I'll introduce Professor of Astronomy and Physics, Enrico Ramirez Ruiz. He is the Vera Rubin Presidential Chair for Diversity in Astronomy at the University of California, Santa Cruz, a fellow of the American Physical Society, and a member of both the Mexican Academy of Sciences and the American Academy of Arts and Sciences. He has co-authored or authored about 300 research papers, 24 of them in the prestigious journals Science and Nature. For over a decade, Ramirez Ruiz has also built STEM training research programs. Ramirez Ruiz's mentees encompass over 200 students, postdoctoral fellows, and junior faculty. The mentoring program he created, called Lamat, which means star in Mayan, has been remarkably successful at increasing the number of historically marginalized students who earn PhDs in astrophysics. For his efforts, Ramirez Ruiz was honored in 2021 by the White House with a Presidential Award for Excellence in Science, Mathematics, and Engineering Mentoring. We're also extremely honored and excited to be joined by 2 graduates from the Lamat Institute, Alejandro Roseli Calderon and Rewa Clark Bush. Alejandra is a Colombian PhD student in the Astronomy and Astrophysics Department at UC Santa Cruz. She works alongside Professor Enrico Ramirez Ruiz on high-energy transient phenomena, simulating the chaotic encounters of multiple star systems. Before coming to UCSC, she earned her master's degree in theoretical physics at Brown University in Rhode Island and her Bachelor of Arts with highest honors in physics at Clark University in Massachusetts. She participated in the Lamat program in 2021, which led her to decide to pursue theoretical astrophysics. She has been a mentor and active part of the Lamat program ever since. Rewa Clark Bush got her introduction to astrophysics as a community college student in the Lamat program in 21 and 22, mentored by Professor Enrico Ramirez Ruiz and Dr. Samantha C. Wu. She has received multiple presentation awards for her Lamat research, in which she simulated the evolution of stars that encounter a black hole and live to tell the tale. Bush went on to earn her master's degree in astronomy at Wesleyan University, modeling interstellar cloudscapes for the New Horizons mission. She will be starting her PhD next fall in the astronomy department at Yale University. If you have questions for Enrico, Alejandra, or Rewa, please type them in Zoom's Q&A box right in the middle at the bottom of your screen. You don't have to wait until the last minute. You can type those questions at any time. If you see someone else's question that you like, you can upvote it and we'll ask it sooner. This talk is being recorded. In a day or two, you'll be able to find it on the UCSC Arts, Lectures, and Entertainment YouTube channel, and you'll get a thank you email from us with the link. All right. Does everyone have their steins? Great, I've got your slug. Professor Enrico Ramirez Ruiz.
Hi, thank you, Mike. Thank you for the opportunity to be here. Thank you, Alejandra and Raywa, for being here. I'm gonna share my slides and get started. Wonderful. Yeah, let me see if I can. Okay, I just wanted to make sure that I can see Raywa and Alejandra. Well, it's a pleasure to be here with you and share our efforts in really trying to create scientific excellence in astronomy. And we're going to tell you a little bit about the Lamat Institute. We have prepared a talk in which we're going to tell you a little bit about the construction of Lamat, sort of the principles, the philosophy behind, but we'll also tell you a little bit about the science, and the three of us will go back and forth, and we'll see how it works. So just so you know, Lamat means star in Mayan, and it started about 15 years ago, and before we get started, I think I'm gonna pass the opportunity to Raywa to introduce you to some of our principles in the form of a poem.
Thank you, Enrico. We wanted to start out with this poem from Kimberly Blazer, who's an Indigenous activist and environmentalist from the White Earth Reservation in Minnesota, and also the founding director of the literary organization INAPO, Indigenous Nations Poets. And the poem is called About Standing in Kinship. We all have the same little bones in our foot, 26, with funny names like navicular. Together they build something strong. Our foot arch a pyramid holding us up. The bones don't get casts when they break. We tape them, one phalange to its neighbor for support. Other things like sorrow work that way too. Find healing in the leaning, the closeness. Our feet have 1/4 of all the bones in our body. Maybe we should give more honor to feet and to all those tiny but blessed cogs in the world, communities, the forgotten architecture of friendship. So this poem embodies the framework that Lamat uses to think about co-creating mentoring relationships of care in science. Probably when many of us think of a scientist, we picture Newton or Einstein, and there's this myth of the brilliant scientist alone in the lab. But when we really dig into these figures, we find out that behind the genius is a whole myriad of partners and collaborators, that genius relies on this forgotten architecture of friendship. And that's true not only in science, but in life. We all know this, all the way down to the example of the tiny bones in our feet. So small on their own, but so strong together, enough to hold up our entire being. And we know that when we're in pain, we find solace in being able to lean on someone, whether it's a personal sorrow or a terror at the state of the world and our uncertain future. Sometimes we need someone else to believe in us, or to believe that there's hope, until we can believe it again too. And so as Lamat is trying to reimagine leadership and mentorship, we're thinking about leaders not as someone who's strong enough to go it alone, but someone who knows how to build splints and build networks of support and a community of resilience. And that, just like Kimberly Blazer says, it all comes down to these tiny blessed cogs, that the world is built cog by cog, act by act, piece by piece, doing our best to hold up the whole. So Alejandra is going to share a little bit more about how we think about mentoring in that framework.
Thank you for your words, Rawa. This is a quote by Jedediah Eiler. Mentoring at its best is world building. Co-creating a future is desired but unfinished, helping to catalyze dreams into reality. I think this is part of the mentoring definition that we carry through with Lamat, and one that has been really close to me, both as a mentee and as a mentor. Science is inertly like a collaborative science. So it's like astronomy is a collaborative science. We see so many of these definitions that Rawa mentioned of scientists in isolation, like Newton, Copernicus, Galileo. But in reality, nowadays, science is very different. Not one single person owns a huge telescope. It's all about collaborations from different parts of the world. I think this has been something that is important to note and realize in the change of definition of mentorship. It's not the mentor who gets to publish with their name. It's both of the mentee and the mentor and their relationship to advance knowledge. Both of us are co-creating, and I also say co-learning about these new topics, just because research is not, there's no one solution and no one right way to do things. It's more like trying to find an answer that lies hidden in the universe. So that's what the importance of having community and mentoring, a community of mentoring.
Yeah, thank you both. And I think just something that is incredibly important is also how when we come together, the impact of the science that we do, the power of the science that we do is so much stronger, no? And I think this is Ray was want to share another way of the way that in the program we think about co-creation and we think about community and how intertwined they are, no? And I think something that we really think about the Lamat program is also how to eradicate this idea of individualism as success and really how do we succeed as a community.
Absolutely. In the past, we've had a very individualistic notion of how to become a scientist. And you might have heard of the leaky pipeline, this idea that the issue with representation in science is that people fell off the conveyor belt along the way, as if there was this one pipeline, this one way to become a scientist, when in truth, there are an infinite number of ways to be a scientist. And a better metaphor might be, instead of a pipeline, thinking about an ecosystem that is flourishing together, where all different species with all different needs are able to have those needs met. And this image is kind of showing us a wonderful example of this, how we know forests are connected underneath the ground by these mycelial networks of fungi. And this kind of mushroom network cannot exist without trust. The mushroom communication highway is recognizing and believing in their collective ability to receive and channel nutrients where it's needed, to protect against parasites, to expand roots into necessary sites of growth. This network process also fosters intergenerational relationships that welcome the myriad of ancient wisdom and connections that reside in older trees to the benefit of younger trees. And these mushrooms affirm a commitment to building relationships of trust that encourage all life to bloom in the forest, because the well-being of one tree depends on the well-being of them all. And that is really a sentiment that we aspire to embody more and more as we organize our own scientific community. And Enrico will share how that's happening in Lamat.
Yeah, and I think for me, when I reflect about my own journey, so this is sort of a map of all my collaborators, which I have written papers with, and the strongest branches and roots, all point out to my students, my former students. So this idea of how we all are interconnected, how we work and support each other, and how we create science together is kind of so this is sort of my genealogy tree in terms of support and care and brilliance. So something, in Lamat that we think of is, how as a unit, how do we support each other? How do we support each other both, in our technical journey, in our intellectual journey, but also, a network of support where we care for each other. And, this brings me to thinking a little bit about how we have to reimagine science. This is from the State of the Profession, from the decadal survey that I was honored to co-chair, where we said, the pursuit of science and scientific excellence is inseparable from the humans who animate it. And, we define scientific excellence as the equitable optimization of knowledge, infrastructure, and innovation, which includes, of course, technical and non-technical contributors, stakeholders, which it's shown, time and time again that we produce higher quality and more innovative outcomes. So by this definition, true scientific excellence is not possible without equitable participation. So when we were thinking about the inception of Lamat, we were thinking about there's so many voices that are in the conversation that they haven't been catalyzed. There's so much talent out there that we haven't been effective at really amplifying. And a lot of it has to do because we inhabit structures that were sometimes constructed to leave people out and not include them. And for us, it was really important to create structures where, people didn't have to leave their identity behind in order to belong. But really how you construct, new ways of thinking, new ways of being, new ways of operating that ultimately will lead to, incredible scientific output. And, I wanted to sort of highlight where we are in astronomy in general and the work that still needs to be done. So within the professorate, African Americans comprise only about 1% of astronomy faculty. Latin about 2%, and an astounding fact is that in the entire country there are 2 indigenous faculty members in the whole astronomy, and there's about 38 astronomy departments, and one has both African American and Latin faculty, which is UC Santa Cruz, and then 20 departments have neither, and of course, as you alluded to, there's certainly not representation of indigenous faculty. And then here there's basically a census of, particularly when it comes to women of color, and this is where intersectionality plays a really important role, where you have both gender and race, where really we have to make very, very intentional efforts to make sure that we support those individuals. And what is shown here is that in the past, this is about 10 years old. I'll tell you a little bit about the impact that Lamat has had, but in reality, just so every year you have tens of thousands of undergraduates that are graduating with a undergraduate degree in physics and astronomy, and women of color are not are a really, really a small fraction of that, and we're not able to catalyze that talent in ways that are effective. And in general, this is, I think, the way that the field is thinking about this, that we really need to modernize our core structures. We need to change our approaches to mentoring, and we're going to talk a lot about that, and you heard a little bit about that. We have to change the way that research funding is actually provided, where resources, institutions, are, that under-resourced institutions are not disadvantaged, and there's more equitable distribution of funding, and also that there is a reward for individuals could carry those needed systemic changes. And we have to reimagine what a great scientist is. And I think, I cannot possibly imagine a great scientist that is not an effective mentor and is not able to care for others. Leadership, education, I think this is work that is being going on at UC Santa Cruz, very impactful, how we change from traditional lecture to inclusive pedagogy and research-based instruction and active learning. I'll show you some examples of that. And of course, community engagement, really from changing this idea that we have from water impacts to really think about mutually beneficial community partnerships. And I think in general, something that a reflection that I like to make is that really solving some of these issues is, requires as much vigorous intellectual engagement and commitment than any other daunting problems we pursue, from, origins of life, the nature of dark matter, the nature of dark energy. And I think really only by properly supporting the people who do the science can we really maximize, the return of the nation's investment in fundamental research. So, Lamat, I wanted to amplify the voices of our advisory board and our wonderful staff. These are people that, are deeply committed to the cause. So I wanted to highlight them. I wanted to also tell you that, I'm incredibly lucky to be a faculty member at UC Santa Cruz, where, the department has really embraced the program, where a lot of my colleagues are really active mentors. And in particular, I think the program really thrives because of our grad students, and this become more clear as you get to know both Raywan and Alejandra more. But I think their commitment to being incredible mentors is being really transformative. The Lamat program also was, completely altered in incredible ways by my collaboration with Professor Rebecca Covarrubias, who's a professor of psychology at UC Santa Cruz, who really challenged, along with two of her wonderful grad students, Kath Quinteros and Tiffany Lockett, really challenged us to think about, are you constructing a program that best support the students? And what are all the dimensions that the program has to think about the support for students? And, they led us through some really deep critical assessments to restructure the program to better support our students. And, this is a reflection that happens every year, and a reflection where, we always have to update our practices. But, I'm deeply grateful for the collaboration that I have had with Becca and, her wonderful input to the program. And it's also incredibly important for scientists to really realize of the incredible value of social scientists, particularly when thinking about designing programs to support individuals. So I'm going to sort of establish a little bit some of the, the big issues that we have in the field. So this is basically a flow chart, highlighting how effective or lack thereof, we're able to support students. Here, AHN stands for African Americans, Blacks, Hispanic, Latin American Indian, and Alaska Natives. So the key that I want you to take from this slide is that what we know is that
Enrico,
yeah.
You intend to be sharing your slides right now? I don't see your slide deck.
I am sharing my slides.
I can see them.
I can see them as well.
Oh, sorry to interrupt. Maybe it's just me.
Oh, no. If anyone else has issues, I don't know if in the chat there's if people can see the slides. We're all good.
Yeah, we're all good. Go ahead.
So yeah, the reflection that I wanted to guide you through is, if you ask undergraduate students that enter university whether they want to be physicist or astrophysicist, those that says yes, by all means, I cannot imagine my life without being a physicist or an astrophysicist, is completely representative of the population of college students. And it's really in the introductory courses where a significant fraction of students actually drop out of the major. So particularly in the introductory courses, women drop out of the physics major at a rate that it's, the national average is about 4 times, and students of color anywhere between 6 to 8 times, depending on the program. So, the way that those courses are taught and the sort of discriminatory practices that sometimes they engage in, have created a huge depletion of talent there in the so-called pipeline, as Ray alluded to. And then, the other big instance is really retention from first year to PhD. So what fraction of those students, apply to grad school and are accepted at grad school? And when you basically compare the numbers, you have factors of tens, from 10 to 70 times. We're losing those students because of the lack of support. So something that we thought of in Lamat was, well, how could we actually effectively support those students? And we thought, one avenue is that we can try to intervene of how those courses are being taught, particularly at UC Santa Cruz. And there's some efforts, but that's a long-term effort. But at the time, there was Janet Napolitano had made the mandate for us to support community college students, that a third of our population should be community college students, and a lot from so-called minority serving institutions. And, those are students that have already, like Reiwa, they have already had incredible teaching at the community college. They're well prepared and they're ready to transfer. And they sort of have bypassed these introductory courses. And that's how, Lamat came to be, thinking about, well, how can we bring those students to UC Santa Cruz from community colleges, historically Black colleges and universities and tribal colleges, and let's support them. And I think a key, just so you get a feeling of the timeline, is because the students are engaged in research so early, they have multiple summers to engage in research and to be supported throughout the entire time. And, we now support students. The program has grown so vastly that we now support students not only at UC Santa Cruz, but, everywhere. And we continuously, they continuously come back for doing research in the summer. So the ability for them to do research right away and for them to create that science identity, it's been really essential for us. And, just broadly speaking, what we think about doing is we, of course, how we recognize, endorse, and invest in students is incredibly important. How we integrate their perspective and amplify their identities. How we create opportunities of growth and promotion. And I think more importantly, be open to the ways that they may unsettle current power structures. That's really important for us to make sure that their voices and their ways of being, and if we have any way of being that it's really not supporting them, allowing them to have a voice in restructuring the program that they want to inhabit, both as the students and as mentors. We have three pillars, broadly speaking, in Lamat. This is how we have a pillar that it's really thinking about examining power and identity. And here, I think I'm going to let Alejandra read some of the reflections and maybe make her own reflection about how the program and the components of the programmatic really create an introspective of, who the students are, their value, elevating their perspectives. Ale.
Yeah, I'll be reading these three quotes. Those three quotes were from the post-program surveys after the students spend the summer at Lamat or working with Lamat. This program is groundbreaking. Many STEM students struggle with the aspect of giving up their cultural identity to adopt a more professional one. Being a part of Lamat, I was reassured that I don't have to sacrifice my integrity or aspirations to contribute to causes like social justice for the sake of making myself more marketable in a professional setting. Navigating through the academic field can make anyone feel intimidated and doubt their capabilities. Now, having completed the Lamat program, those feelings are non-existent, and my academic path has never been more clear. Another student commented, I gained more confidence in myself as a researcher and as a speaker. I was very proud of my final presentation and enjoyed engaging with my research project and mentors. Lamat gave me a community I felt I was missing, and I felt a huge difference in how I see myself in the field. A third student commented, "Thank you all for this amazing opportunity. I had applied to Lamat in a moment where I was almost about to quit science, but Lamat has given me the passion and confidence to continue in science and astronomy. I love you all. Thank you." This is just a small subset of the many comments that we get, both during and after the Lamat program. It might feel like 8 weeks in a science summer program is not a long time, but it clearly shows that the investment that Lamat has in its students is lifelong and life-changing. I can personally attest to the fact that being able to have a community to rely on can really change your perspective, especially in a setting where you might feel like you have to leave things aside to be your true self in science and to be accepted in astronomy. I think in the case of Lamat, there is a lot of support before entering the program, during the program, and many years after. So many of the students feel reinvigorated after spending a summer in Santa Cruz, which it's also a beautiful town. So the community also is it's very helpful to have a very beautiful redwood forest to be learning science. But I think after that, we also receive a lot of support in terms of classes, applications, and even career changes. So I think that those 3 quotes just show like a bit of a snippet of what the summer was in order to support the students in like lifelong changes.
Yeah, thank you. Raywa, do you want to?
Oh, sure.
Oh, I thought you were unmuting. Sorry, but
No, I mean, I'm happy to share. These quotes make me smile so much, because I have also struggled with feeling like I couldn't imagine myself as a science. I didn't see people reflected in the scientific community who held the values that I held. And I found them at Lamat. And it just filled me up with this sense of hope and passion that, oh, we can actually go and create the scientific field that we want to be a part of, and one where we all get to be our full selves. And that's just a really transformative thing to be a part of, and know that where even after we leave the program and we go to institutions all over the country, we're taking those seeds with us and we're going to nurture them and grow them each in our own communities, and it'll spread.
that's beautiful. You know, and you know, something that it's of course incredibly important is to support those students in doing the science and giving them the tools. And you know, we think a lot about project design and research support structures. We think very, very thoughtfully about, you know, we never really attempt to ask a student to do something that we haven't trained how to do, you know, and we guide them through the learning process to become independent scientists. No, so there's only a lot of structures of support, but there's a lot of community learning together and a lot of you know, debugging together, writing together, and making sure that we, you know, that we as mentors are able to create, you know, pedagogically well-designed projects. And I think this is something where I think science is missing, to really think about the pedagogy of project design. And this is something that we think about carefully. And of course, you know, sometimes it develops over multiple summers. So you have to think very intentionally about how you're, you know, slowly giving the tools necessary for the students to blossom. And as you will see from the outcomes, you know, they always do. So another really important component is that we want to provide the mentors the opportunity to be effective mentors. So, you know, both faculty, postdocs, and grad students, we engage in mentoring training, in creating a mentoring community of care, of supporting each other. So that's been another really important component of the program, in really thinking about being introspective about our practices, how we're supporting students, and how we can actually provide students with these networks of mentors, not one single mentor, but how can we all as a program come together at all career stages to support each other? I'm going to, I think, let Rewa start us thinking about the mentoring practices. This is a beautiful reflection from Victoria Molero Gonzalez, who's the director of mentoring, who basically thinks about what are the practices that you can create effective mentoring relationships of care.
Thank you. And I'll bounce back and forth with Ale. So the first practice is self-awareness, which is a muscle exercised through constant reflection. So there isn't a moment where we are fully self-aware, but because we are always having impacts on others around us, and therefore we are constantly in a state of learning about ourselves and about how we inhabit the world and what impact that has. So that's a muscle that we're trying to develop in Lamat as mentors, is really understanding how our words land with others, and do self-reflection on how we can bring that more in alignment with our values.
The second point is to be radical, be transformative, grasp things at the root. And as scientists and physicists, a lot of us do that in our academic career, trying to get to the bottom of a problem, starting from first principles. But it's a lot harder to do these reflections on yourself. And maybe that's one of the things that you also look for in therapy. But in this case, it's kind of like learning about how you were taught and how you have biases, and being able to support and change those from the root to stop spreading.
The next practice is that words are matter, and words matter. Our words have an alchemy, the power to transmute and transform, and we need to choose our words carefully, with care and intention. I feel like everyone has a story from when they were in school and there was that one teacher that one time who said, you know what, you've got what it takes. I believe in you. And we hold on to that like a shield for years. And I think that's such an example of how words do real work in the world. They transform us. And we want to use words with care, knowing their power, and use words that help build each other up and strengthen each other.
Recognize the limits of your understanding. Trust the breadth of others. This is one that has always been a bit of a challenge to me. And I think it has been really important and transformative to be able to understand that there are limits to my understanding. As a person, I've only lived my life, and I cannot fully understand or grasp the whole universe that is behind another person. And I think that one of the things that has been very good to constantly exercise is the trust of the breadth of others. It's obviously not easy to fully trust someone, especially someone who could be a mentee that you just met, or someone who maybe you have not ever worked with before. But I think it's one of the things where you have to let go of the fear of trusting in order to discover the beauty of the science, the beauty of physics, the beauty of astronomy that lies within. So this goes very hand in hand with reflection and exercising reflection, because it's exercising trust in everyone's ability to succeed.
Yeah, and it's so important to know when we create knowledge to really value the emanating knowledge of everyone and give them the opportunity to speak, to express themselves. And sometimes they don't necessarily have the same language that you, because you've been trained in that, but thinking about what is it that they mean, and ultimately that ability to listen and in the creation of knowledge always invariably lead to incredible outputs.
The next practice is to use the present to practice future making. The vision is to build networks of care, to heal together, and we do that by weaving one relationship at a time. So if you think back to that image of the forest with all of the green tendrils interwoven beneath, it might not seem like building a relationship is going to have an impact on your career or the integrity of your science in the future, but it is. It's building that strong foundation of support and of trust that is going to create that strong forest in the future.
We are each at once multiple and singular. We're all works in progress. See the complexities and the simplicities and take them as they are. And I think that's something that is just very reflective. And I, as a mentor, we have weekly or bi-weekly trainings to reflect on all ourselves and our work and how we're still works in progress. I think it's really easy in science to see someone who is more advanced as a person who knows everything and who is already done. They know all that there is to know. But in reality, they also have many questions, maybe even more questions than we do. And they're still trying to solve and find the answers to those questions. In many aspects of science and in academia, it is very simple for other people to ignore the fact that they are human and try to ignore the fact that you're also human and just see you as a work machine and someone who is constantly at a stage in their life where they have to publish more, learn more, take all the classes and succeed, whatever that means to them. But in reality, we're all still part of our process. And it's not easy or simple to feel like if a person is at the same stage as you or at the same stage you were before, that they have the same knowledge, the same background, the same multiple and singular self. So I think it's one of the moments where I've had a lot of time to stop and reflect in my relationships with both my mentors and my mentees as we are learning and co-learning together.
This next one is to care for yourself so you may care for others and let yourself be cared for. This makes me think of hanging out in my office at the observatory in grad school and how, day by day, so many younger students would come by my door looking for support, for advice, whether that was like how to figure out this code or how to navigate career pathways. And in order to hold space for them, for their fears and their hopes, I need to first make sure that I'm taking care of myself and that I'm well. But then also when I was going through the absolutely terrifying experience of applying to PhD programs, some days it was those students stopping by my office who gave me a pep talk. And because they had seen me shine, they were able to remind me of that capacity in myself and that I did have what it takes. So there's this give and take in how we mutually are caring for each other and ourselves.
It's beautiful. Yeah, and I think, in as a community, we choose, to care for each other, to be there and to support each other and to to really pay attention for everyone as a community. And if everyone is struggling, if someone is struggling, the community struggles. So I wanted to just highlight that this intentionality has led, strong impacts. We have really supported the increase access to PhD. This illustrates one of the aspects, which is Latinx students. More than about half of students currently in PhDs, students of color, are from Lamat. And kind of creating those pathways to the profession. You can see there that, particularly there's significant amount of work to do related to African Americans, and this is something that we have engaged, into doing, much more intentionally and have increased representation significantly of those voices, you know, and particularly with our partners, with particularly HBCU universities, and, you know, building trust and support for the community. I wanted to sort of end this component before we talked a little bit about the science, is that yes, that we you know, we've been around almost for a decade and a half. We have supported 154 students as of last summer. 2/3 of our participants belong to historically marginalized communities, and in some ways that's the design of actually advertising and bringing students from community colleges, historically Black colleges, and tribal colleges. 2/3 of the students are first-generation college students. 90% of students actually have gone to grad school, and we are very thoughtful at saying, you know, if grad school is your goal, we'll support you on that, but we want students also to define their own pathways and their own success. About, you know, half of the Lamat transfer students have published a first author paper, and that tells you, you know, this idea of continue working on a project for more than one summer. Astrophysics Lamat students at UC Santa Cruz are 6 times more likely to be accepted to a top grad program. And, you know, as we alluded to, Lamat has helped double the number of historically marginalized students enrolling in top grad programs. Something that I think we are very proud, and you see this in Alejandra, is that 1 in 5 of our astronomy grad students at UC Santa Cruz are Lamat students. So this is also a way for us to attract students from all over the country. We get something, you know, close to 200 applicants for 10 positions every year. So we're able to really attract a lot of talent to our program. 1 in 3 of all the NSF graduate fellows that belong to historically marginalized groups are Lamat students in the entire country, which means that our students are 4 times more likely to get these fellowships, which are the most prestigious fellowships in the country. And then, you know, our Lamat students' success stories continue, you know, as they transition to postdocs and faculty, and that's something that we're incredibly proud of. And now many of the Lamat students that are faculty are coming back in being mentors, and that has, you know, been drastically catalyzed by venues like this where we can do things online. Anyway, I think as Alejandra mentioned, you know, we want to support the students all the time, and we're constantly providing them advice as also they're applying to faculty positions now. So the program has gone for long enough that we have seen, you know, all career stages, and now we have, you know, we're starting to have a critical mass of faculty of color actually that come from our program. Okay, so we're gonna switch. I think we maybe talked a little bit more slowly than we planned, but we're going to switch to tell you a little bit about the science, and I'm going to just let Raywa and Alejandra tell you about, you know, a reflection about their science and about their experience within the program. So Ale.
Yeah, we wanted to have the opportunity to talk about our science because that is our favorite thing to do as scientists. And a little bit about our experience at Lamat. So you can go to the next slide. Mike introduced me and Raiwa at the beginning, but we thought we would also have a little bit of an introduction. I'm Alejandra. I'm a 3rd-year PhD student at UC Santa Cruz in the Astronomy and Astrophysics department, working with Enrico Ramirez-Ruiz. I'm a Lamat alum from the summer of 2021. And then I went on to become a Lamat mentor in 2023 and 2024 during the summer and continuously during the year. It starts as a summer commitment, but it's definitely a 12 months per year commitment at the end of the day. And for my Lamat project, I already have one first author publication. And there's more on the way from my mentoring experiences. So I'm really excited about my paper and being able to talk about it. Today I'll be talking about some really funky stars called blue stragglers. And I decided to call them in this talk the stars that shouldn't be, because they are a bit of a puzzle. So I'll start by showing you an image of a globular cluster with some blue stragglers. Some of the blue stars that you see up here are blue stragglers. We think that this cluster of stars was created from the same cloud, the same material at the same time. And the stars are all different sizes, masses. And if we go to the next slide, we can see how they are divided up. Scientists love to find trends. This is one that astronomers love, which is a luminosity temperature diagram. So we're classifying the stars. On the y-axis, you can see the luminosity. Things up top are brighter, things at the bottom are dimmer. And then at the bottom, on the x-axis, you'll see that the axis is surface temperature. Things that are hotter are on the left and colder on the right, which is a little bit non-intuitive. But it gives this beautiful shape where we have in this like bottom area of white blue, stars that are white dwarfs, very dim. And then we see in the middle, kind of like a diagonal line. And we call that the main sequence. You might have heard that before from the sun being a main sequence star, or from astronomers saying like, oh, the main sequence. These are stars that are living the best years of their life, just burning hydrogen around our galaxy, or in this case, around our globular cluster. Stars that are bigger in this diagram are brighter and hotter. So they're the blue stars at the top left of the diagram. These stars have a higher surface temperature. So it's causing them to burn through their hydrogen just because they're bigger, faster than the rest of the stars. So even though they're very luminous and very beautiful, they're short-lived. As these stars end up burning all of the hydrogen that they have to start burning helium and then bigger elements, higher metals. And they start to move to the right towards the red area where we call them red giants. So if we look at a sample of a globular cluster, just as we see it originally being born, all of the stars should be in this beautiful line in the middle, the main sequence. And there should be some big stars, some small stars, some tiny, tiny little ones, all shapes and sizes. But as the globular cluster starts to age, these bigger stars are gonna move to the right and become red giants. Sometimes people say they die, but I don't like thinking of them as dying, just transforming into a different form of star. I think there's a lot of negative connotation with space. And so as time progresses, the bigger stars left are the ones that are evolving out into red giants. And if we go on the next slide, we'll see that you can, or astronomers try to put an age of a cluster by fitting these lines to where the stars are going from being in the main sequence to being red giants. So as you can see, the top line is for 5 million years. And then as time passes, 20 million years, the stars that were bigger are no longer there. They have moved right to the red giant era. Then 100 million years, 1 billion years, 10 billion years, and slowly, you will see less and less of this very massive, very bright blue stars. And more of the ones that remain are just smaller yellow, red, sun-like stars. But looking at many clusters yielded something that seemed to not fit with this theory of our stars. And if we go to the next slide for this cluster called M55, circled here in teal are a group of stars that are very bright, very blue, but they shouldn't be there. All of the other massive stars have evolved to the right, as we see with that yellow line that becomes the red giants. So what happened to the stars? Why are they there? We can go to the next slide. Why do we see them? Next slide. And one of the possible explanations that we have is that these stars actually go through interactions. So there are 2-3 theories of how they formed. The one on the left is two stars in this dense environment full of stars, which is a globular cluster, are moving around, and at some point they encounter another one face to face, and they collide in this beautiful, bright, chaotic event. And then this gives more hydrogen to the star, making it blue and very bright, but it seems like it would have been as old as all the other stars, but in reality, it is just as old as the two smaller ones together. Another theory is that two stars in a binary are orbiting each other, and one of them starts taking mass from the other one and doing a mass transfer. This way, it's getting new material, new hydrogen in, and eventually it engulfs most of the other star, becoming this blue bright star. In the next slide, I'll show a simulation of what that looks like and how we model it in astronomy. So this is a simulation showing the two stars, a close approach, and all of that red that you see around is material that they're sharing and they're tossing around until they collide and they form this bright and blue blob in the middle. And the simulations happen over the course of 4 days. So this is a pretty fast event and pretty dramatic event. In the next slide, this is connected to some of the research that I am currently doing at UC Santa Cruz, because I study stars that live in partnerships or in communities, such as binary stars, triple systems, and stellar clusters. Some of these outcomes, like blue stragglers, can never be reached by stars in isolation. They have to have another star around, a partner or a triple, or a lot of other friends in this community to make them shine bright and blue past the age that they would have lived. We can go on to the next slide, and I'll show a little video from my personal research. This is not exactly a blue straggler, but it'll show a bit of the simulations that I'm working on about this beautiful stars that are just much more shiny and have all this chaotic events going on only because they encounter another star. And I love the fact that these are processes that we would have never imagined when we were first learning about stars, because our sun is alone right now. But it is so beautiful to think that in this huge clusters of stars, all of this fun physics is happening. I think we can go to the next one. This is a bit of a long video. Some of the connections of this story with my experience are that, similarly to this blue stragglers, I believe that I could not have reached my full potential in isolation. I'm a firm believer that having Lamat as my community of care and support was key to reinvigorating my love for space, connecting me with brilliant scientists at all career stages, and solidifying my scientific identity. I've been able to talk to people about black holes, both in outreach ways and also in conferences with people from other countries. So it has been an amazing experience for me to grow from my community. I think, Rewa, you're up next with your intro.
Thank you. It's so wonderful every time I get to hear about your research and what you're uncovering. As a reminder, I'm Rewa. I am joining you right now from Joshua Tree National Park, where I'm an astronomy educator through the Scientists in Parks program. I was a Lamat alum in 2021 and 22, and I'm working on a first author publication from the research that we did together. And then I'll be starting my PhD at Yale in the astronomy department next fall. So what I want to share with you is another example of a stellar community where these kinds of fruitful interactions are happening, and that's the Galactic Center. So we can play this video that was created by Andrea Ghez and Silvana Yelda and the UCLA group. It's a 3D movie of the stellar orbits in the central parsec of our galaxy, which a parsec is about 3 light years. And this data was obtained from the Keck telescopes from 1995 through 2012. So they've been observing for a long time to see the orbits of these stars and then extrapolate them out. And what they found is that the center of our galaxy is dominated by an invisible mass at the center. Everything's rotating around something that appears like it should be there, and turns out it's a supermassive black hole with a mass 4 million times that of our sun. And it's drawing these stars in, so it's a very crowded area within that central parsec. It's estimated that the number density of stars is about 10 million stars per cubic parsec. 10 million compared to the 0.2 stars per cubic parsec that's more characteristic of our solar neighborhood. So this is an incredibly dense area where lots of stars are in community together. And in such an environment, stars can sometimes get bumped into a close encounter with that supermassive black hole at the center. And we know that that black holes warp space-time with their extreme gravity, and you can only get so close before weird things start to happen. Here's an example from Jamie Law Smith, whose work my research is based upon. And he simulated this little pink star heading towards a supermassive black hole that's depicted by the gray circle in the center. And that's the depiction of the event horizon of the black hole. And when the star reaches this white dotted line called the tidal radius, this is a special threshold, at which point the gravity of the black hole pulling on the star is as powerful as the star's own self-gravity holding it together. And so the star kind of gets pulled apart like taffy. It becomes disrupted. And you can see as the star continues on its orbit that this green arrow is showing some material is torn away and becomes bound to the black hole. The blue arrow shows some material is unbound off into space. And then sometimes the pink arrow shows there's this surviving core. So in the next slide, we'll play a video of a tidal disruption event from the perspective of the star. So when these stars get disrupted by reaching that tidal radius, we call this a tidal disruption event, or a TDE. And you can see these waves coming off of the star as it's being pulled and losing material. And it's incredibly beautiful and a very vibrant event that can be seen in galaxies across the universe. It was thought that TDEs resulted in the annihilation of the star, but actually there is a massive diversity of stellar experiences depending on how close the star gets to the black hole. We call that its pericenter, or its distance of closest approach, which can be seen kind of at the bottom of these parabolas. So for example, a star that follows this blue trajectory and just grazes the tidal radius might only lose 5% of its mass, whereas a star that follows the orange trajectory and penetrates closer to the black hole might lose 60% of its mass, and yet still survive. Actually, these more grazing encounters are even more common. And so we believe that the majority of stars that interact with a black hole actually survive. But these survivor stars have never been studied until now. So in my research, what I do is I study the long-term evolution of stars after they've interacted with the black hole. What's going on with them 1,000 years later, 1,000,000 years, 1,000,000,000 years? And you can see from the plot on the right, we've plotted luminosity, so it's brightness on the vertical y-axis, and time on the x-axis. And the solid yellow line is the evolution of a regular star that has not been disrupted. And it's very stable because it's on the main sequence. It's doing its stable hydrogen burning like Alejandro was talking about. But the dashed lines are my disrupted stars. And you can see that at first they're incredibly bright, so vibrant, they're orders of magnitude brighter than they would have been due to this encounter. And you saw all that sloshing around that happened. Well, that is taking this sort of dormant fuel reserve of hydrogen from their envelope and incorporating it into the core. So they're getting this like rejuvenation of fuel. And you can see they end up living billions of years longer. Their lines extend further to the right of the graph. So they live a lot longer than they would have without this interaction. And it just an awesome example of how these interactions are not just bright, violent events that spell the death of the star, but can actually transform the star into a totally different and fascinating phase. And there may exist tens of thousands or hundreds of thousands of these survivor stars in our galactic center that we've never looked for before. And if we actually pay attention to the survivors, they could hold really important stories for us and provide insights into some of the most gravitationally intense encounters in the universe. So I'd like to connect this to my experience on the next slide. Just like TDEs sometimes take you out of a normal path, I had a pretty non-traditional journey to science. Even though astronomy was my passion when I was a small kid, like many girls in middle school and high school, I lost my confidence in STEM and I turned towards other passions. I became an English major in undergrad and I was starting a career in the arts when I finally reckoned with the fact that my dream of being an astronomer was not going to let me alone, and I had to at least try. And I was taking night classes in community college to figure out, can I even do math, when I encountered Lamat. And it's just amazing to me how far I've come since then. I have gotten my master's in astronomy. I was invited to present at the International Committee on Space Research, COSPAR, their scientific assembly in Korea last summer. And I'll be a NASA intern in a couple of months. And then I'm going on to my PhD. Like, I could not have imagined that for myself. And it's really thanks to Lamat providing the stepping stones, the mentorship, the connections, the funding, and just having a community of people who believed in me when the rest of the world was saying it was too late for me to become a scientist. That helped me build my confidence to keep going. Something that Lamat does that is so powerful and transformative is that we celebrate the unique strengths and experience that each of us bring to the table. That even though I was starting without a bachelor's degree in physics and had never done astronomy research before, already on day one, my mentor Enrico was connecting me with other like PhD students saying, hey, can you help them with editing their essays and their papers? And seeing like, oh, as an English major, I have a special skill to bring and to share. I'm not only the one who's receiving in this relationship, and just realizing that the things that make each of us different are our strengths. That's something that I've really taken away from Lamat. I've also taken away an ability to reflect on the fact that in some situations, the strength I'm bringing is my privilege in a space, whether that's because I might be taken more seriously by a predominantly white faculty, or I'm in a STEM department that's really well funded compared to other departments, and that I can use that positionality to amplify others to ensure that I'm opening doors so that everyone, our whole community, can be built where everyone enters the room and has room in the room to be their full selves. That's a responsibility that I have. And like tidally disrupted stars, we each can come out of these challenging interactions and learning experiences brighter and stronger and rejuvenated if we have that community of support, because strength and resilience comes from leaning on each other. And if we go to our last slide, we might reflect back on that poem that we started with by Kimberly Blazer about the tiny blessed cogs. Remember the wisdom of our feet, that the vision of the world and the field of astronomy that we want to be creating is not held up by one person, but is created by all of us together, holding up each other. So at that, I'll pass it back to Enrico to close us out.
Yeah, I think I'm just gonna open the opportunity for people to ask questions and end in that beautiful note. And thank you, Alejandra and Rewa, just for sharing your experience and your science in such a beautiful way. I'm gonna stop sharing. And this is, if you're interested, this is the website in Lamat. And if you're so inclined to support our program, there's also a donate button there. So yeah, thank you so much, everyone, for being here. And I'll stop sharing and open the floor for questions.
Wow, Thank you very much. I have to say I wasn't prepared for this level of inspiration. Poetry, metaphors, wonderful metaphors, beautiful stories, and then inspiring science. Incredible. So we'll start with Kirk's question. Why mentees instead of proteges?
Well, I think I think we're thinking about of course the idea of protege came from sometimes this idea that you select someone that looks like you, that you think can basically continue your life's work, and you train someone, and generally speaking, where people think about proteges, they come with the underlying assumption that there's a strong connection, that sometimes you see yourself reflected on those individuals. A lot of that, of course, led folks to think of proteges of people that look the same as they did, that they have the same lived experience, and in some ways trying to recreate science based on identity and experience, which, as you know, has led to significant discrimination within our field. And it is interesting to me that the word mentor assumes kind of a power differential, but in reality, I think when enacted effectively, I think I been mentored by both Rewa and Alejandra. I learned from them. They're been my teachers. I've been their teachers, and it's really been a relationship of co-creation and co-learning together. But of course, without forgetting, as Rewa beautifully said, about the privilege that I have for being a professor, the privilege that I have from being able to write letters of recommendation, to have connections, and so forth. So without forgetting about that. So yeah, I think maybe the word mentor doesn't completely encompass what we want, but in reality, they're colleagues of ours, and they're just kind of earlier career colleagues of ours in our journey of learning and understanding the universe. But we have a huge accountability and responsibility as mentors to care for them and to support them and to really elevate their voices. But I don't know, Rewa or Alejandra, if you want to add.
I think you said that beautifully.
Oh, what an interesting question, though. I think it was you, Rewa, who read that quote. The words matter, right? So, what is the distinction between mentor, protege? What do you want to be called, right? We have a question from Stephanie. Thanks for the talk. I'm excited to hear resonance between community college philosophies and Lamat. I'm curious to hear about how Lamat has been seen or received in science circles beyond, specifically those that are not concertedly committed to community and equity. So there's a few questions in there, like maybe you can talk about what is the community college philosophy and how that meshes with Lamat, and then how does Lamat received at some colleges that may not participate?
I'll start out as a former community college student, and then Enrico can go on. I've been to both sort of like elite liberal arts colleges and a bunch of community colleges as I was putting myself back through school to become a scientist. And I really loved my time at community colleges. I was really struck by the culture in which my guidance counselor would not just check in with me about my classes, but also my mental health. They would walk me to the food bank. They would help me apply for scholarships. There's this commitment to really seeing the entire student and addressing all of the barriers that they might be facing so that they can show up fully prepared in the classroom and do their best work. And I also loved at community college that there were students from all different moments in their lives, different ages, different backgrounds. A lot of people like me that were coming back to school later in life, and that each of us were really welcomed and celebrated, that we weren't all a cookie cutter 18-year-old, on this conveyor belt, but able to take our own unique path and be connected with the resources that we need. So, and in my like intro physics classes, which were the hardest classes I had ever taken at the time, I would go to the STEM center and I would sit down with like half the class after school, and we would work through things together, and there would be tutors there and mentors, and there was just this community centeredness where we recognized we would get through it together, and there's a lot of generosity in that. So that's some of like what just happens naturally at the community college that might not be as present at a different institution. Do you want to take it away, Enrico, about how that has been
No, I mean,
received?
I think it is interesting ultimately that, scientists care about the quality and impact of the science, the creative outcomes of scientists. And, Lamat has now a reputation to really create such scientists that it's certainly uplifted, and it's certainly highly regarded. And in fact, it gets to a point in which, the reputation of the program builds on itself, and then these other communities that may not be as accepting, have the opportunity to interact with these amazing scholars, and that are not only doing great science, but they're also advocating for changes within their own departments and making the departments better. So I think, one of the issues that science has in general is that when they think about voices that are not there, or folks that have been historically marginalized, they sometimes tend to see it in a light of in a deficit perspective of thinking about, they're not as well prepared, they didn't have as many opportunities, we have to invest more resources, we have to, and that deficit framing is just so non-constructive, no? And I think what Lamat is basically clearly showing is that, when supported, those voices, can transform the field. They think in ways that the field is not used to think. When we think about being radical, radical means grasping things to the root, So sometimes when folks haven't had, the training that other folks have, they challenge the principles. They challenge, why am I doing this? Why we should be doing that? So in general, I think, scientists value great science, and scientists and the scientific community are realizing that we have to support the humans that animate the science, and that we're missing a lot of perspectives. And yes, I mean, some folks may be exemplified by the past week, not incredibly open to folks that look different than them, that they have different religion, different upbringing, different ethnic backgrounds, and who's, the scientific community was not built to support those individuals. But I think in general, astronomy broadly is being incredibly introspective and incredibly open to change. And so in general, I feel that this is not a UC Santa Cruz phenomena. It's really a countrywide phenomena. And yeah, I think the impact that the program has is just an example that, people are really excited for the students, really excited to welcome them in their departments, and they're also thinking, much more thoughtfully about how can we generate programs like this. How is it that one program has had the impact that it has? Well, just because our current statistics are so poor, but you can imagine the kind of multiplicative effect that this could have in order to support everyone and to have a community that is more representative of all the voices and all the talents that we have.
Alejandra wants to hear more about the history. So you lead up to that. She says, thank you. I'm wondering where you were in your own career when you decided to found Lamat, and how you build a community to found such a transformative program. So a little more of from the start to where you are today.
Yeah, well, Alejandra didn't say that she's a Lamat student.
Uh-huh.
currently at Berkeley. Yeah, I mean, I think for me, everything started when I first visited Harnell College in Salinas. I just have moved to UC Santa Cruz. And I thought, part of the learning and the work in progress that we all are, I felt that particularly, I grew up in Mexico. I thought Mexican Americans, were living the American dream. They had every single opportunity to grow, then they had all the support that they needed. And, when I went to Salinas, it was, a transformative experience for me. I was surrounded by people that came from my own culture, that we have very similar identities. And they were basically saying, we have never seen someone from our community with a PhD, and I spent time with them and I just saw, oh my God, like these folks don't have access to supercomputing. They don't have access to, research opportunities. And and I think at that moment in time, I was like, we have to be able to create, I mean, this is like a huge opportunity, we have these incredible source of talent, and Harnell College is just an incredible community college. So much talent that it's basically not catalyzed by our university. And the Lamat started actually as a partnership between Harnell and Lamat, and then slowly grew to other nearby community colleges. And now we basically are kind of national. So a lot of the story was also a story of growth for me, and really understanding, the structures of oppression in this country, the history of this country, thinking about how you create pathways of the profession, and and of course being embedded in a field where no one looked like me. That was also incredibly motivating for me to think about how you create pathways to the profession to support those voices, with the understanding that their pathways and sometimes their experiences may not always going to be incredibly positive. So I think something in the Lamat program that we are very open about is this sort of discrimination and experiences that they may be exposed to, and how we support each other as a community. How do we hold the field more accountable to change, and to be more introspective about their practices and the support of the students. But yeah, I think that was sort of how Lamat started, and started with one student a year to now almost 15 or so a year. So, and a lot of that is the growth is really, as we said from the previous question, the value that a lot of my colleagues saw in these students is like, oh my God, like, how are you going to mentor such amazing students? I went in and I'm like, okay, yeah, let's expand the program.
Well, let's see. David, do I have time to ask a question? If
you're quick,
I'll take my, as a moderator, I'll take that chance. I have a question about the science for Alejandra. The two cases that you showed in simulation seem kind of similar, but I'm wondering what the difference between them is. Is one of them kind of a catastrophic event, and one of them, where the two stars merge right away, and then one of them is a slow process where it, how are they?
So I guess in the first idea is that they just collide head on. So this two stars are not bound before. They're just floating in space. They find each other just at the right angle, just at the wrong, or maybe wrong angle, wrong place, however you want to see it, but they just collide into each other. And the two cores of the two stars kind of like merge in this kind of chaotic event. In the other one, two stars are in a stable binary. So they've been orbiting one another for a while. And they live in this partnership that is stable. Until something happens, they can get perturbed by another star, or it can be that one of them expands. And the expanding gets really, really close to the other one, and you start stealing material from the other one if you expand. So the other one requires, it's still a chaotic, catastrophic event, but it requires some stability before The other one is more like you're just randomly bumped into a star in the galaxy that day, and it was your day to become a blue straggler.
Yeah, thank you.
Well, thank you very much. All right, I think we need to call it an evening. Let's have a big round of applause down in the Q&A box. You can put little comments for Professor Ramirez-Ruiz, Alejandra, and Rewa. Thank you very much for sharing your wonderful, fascinating stories. And if you would like to support the Lamat Institute, I think a link will be coming up down below, but in any event, it is lamat.science.ucsc.edu. Again, lamat.science.ucsc.edu. Another big round of applause, if we could, for the staff of Alumni Relations and Special Events to help organize this lecture. Thank you, Shana, Diana, Paulina. And our next event on December 19th will also be a multiple header. It will feature not one, but two Slugs and Steins, also rising stars. UCSC Associate Professor of Literature, Renee Fox, and Associate Professor of History, Elaine Sullivan. Renee co-directs the Center for Monster Studies. Elaine is our 3D digital Egyptologist, and they're co-teaching a course this year on mummies. They'll talk about the origins of the class and how it speaks to their current research, Renee's new book on reanimated corpses, and Elaine's current project, which focuses on the movement of Egyptian antiquities into the West in the 19th century. Well, there's more happening, though, on campus before December 9. Of big importance to many groups on campus, including this one, is Giving Day on November 20th. So please check it out at givingday.ucsc.edu and be generous. Again, givingday.ucsc.edu on the 20th of November. Then on December 4th, we're going to have a different angle on science perspectives. This will be at the Santa Clara campus, where the next CRAW lecture will tackle artificial intelligence in the pursuit of science. Professor Prokaska will describe the rise of large datasets in astronomy and oceanography on the sky and the ocean, and then explain how AI enables scientists to perform unprecedented analyses. Information on these events and more are at calendar.ucsc.edu. So on behalf of the UC Santa Cruz Alumni Association, thank you for joining us, and please come back on Monday, December 9th at 6:30. Thank you again.